Hey, welcome to Unit 7, Lesson number 2 in the right triangles unit. Today we're going to be talking about using Pythagorean theorem, which you guys should be familiar with. But first, before we get into that, we need to review radicals and show how to simplify radicals. So for the first 4 questions, they are all perfect squares. So if you use your calculator, second square button, and put the number inside the radical, it should give you the answer. So you would get 10, 7, 13, or 13 and 20. If you square all those numbers, they'll give you the answer, which is inside the radical. Okay? That's a quick review. Now, I want to show you how to simplify radicals that don't have perfect squares in them. Okay? Now, this is what you need to do. First, you can put it in your calculator in the y equals. So if we have square root of 128, you need to put y equals 128 divided by x. And then hit second graph, so it'll show you the table. And that'll help you create a factor tree if you need that to create a factor tree. Now the key here is you want to go down the line and use the factor tree until you find each number that is prime. And then you're going to look at all the numbers that are left and multiply them together. So let me show you that. So over here, we got 2 and 64 first. Okay? And then 64 factored 8 and 8, and that 4, 2, and then 2, 2 at the bottom. So if we were to write this all out, we have 2 times 2 times 2. Okay? And then we have another pair and another pair. So 4 more 2s. Okay. So now what you want to do is, for each pair of 2s, pull one of them out. So we got first pair, we pull one out, and then one disappears. We pull the next one out, and the next one disappears. We pull the next one out, and the next one disappears. And then if one doesn't have a pair, that's what's going to be left in the radical. So if we go outside, we did it 3 times, so we have 2 times 2 times 2 radical. And then we have this one, which didn't have a pair, so that's just left in there. So 2 times 2 times 2 is 8. So that's going to give us 8 radical 2. And it's just as simple as that. So that's when it says circle the pairs of prime numbers. That's what I did. So we had 3 pairs. For each pair, one moved outside and one disappeared. So that's why I moved one out and crossed one out. And then the last one, anything left unpaired, which was that first 2 at the top. Okay. We just put that back in the radical. It was only that one left out, so we didn't multiply with anything. Okay. Now if we look over here at 192, we got, and I always do 2 if it's an even number because you know it's at least divisible by 2. So we got 2 and 96. 96 is 2 and 48. 48 is 2 and 24. 24 is 2 and 12. Okay. Now I'm going to cheat here. Instead of doing 2, I'm going to do 3 and 4. And then 2 and 2. It's our final pair. So now we have to do the same thing. We got pairs of 2s. They don't have to be on the same row to be a pair. So we got one pair, we got another pair, now the 3 is unpaired, so I'm gonna leave that alone for now. And then we got another pair of 2s down here, and then the 3 is unpaired, it's prime. We got times 3. Okay. Now we do the same thing. Move it out, cross one out. Move it out, cross one out. Move it out, cross one out. So the only thing left unpaired is that 3. So we got 2 times 2 times 2 on the outside. Then we got the 3 on the inside. So that would be 8 root 3 for the final answer. Okay. Now I'm going to give you the answer for number 5 to get you started. Okay. But then I'm going to want you to do 6, 7, and 8 on your own. So for number 5, when you finish doing the factor tree out, you should get 2 root 14 as the answer. Just to make sure you're doing it right. Then you can do 6, 7, and 8 on your own. And we'll go on to the next slide. So now we're going to be talking about the Pythagorean theorem. So the first thing we need to do is talk about our radicals. Our hypotenuse. So the hypotenuse in a right triangle, as we talked about in the first lesson, is always opposite across, whichever word is better for you, from the right angle. Okay? So it says label and name the hypotenuses in each of the following diagrams. So we have right angle, opposite across is our H. So AC is our hypotenuse. And it's as easy as that. So do 10 and 11, do 10 and 11 on your own. Should only take you a minute. Now we're going to look at the Pythagorean theorem. Okay, that's just a squared plus b squared equals c squared. So square both of the legs, add them together. And if it's a right triangle, okay, it should give you c squared. They should be equal. So if you see an equal sign, you know it's a right triangle. That's what tells you that it's a right triangle. And I like to point that out because we're going to learn about different types of triangles in this lesson as well. So finding the length of the hypotenuse is just as easy as adding and taking the square, squaring, adding, taking the square root. So we have 2 legs here. We know that we have the legs because across opposite is the hypotenuse, so that's what we don't know. So we know we got 20 squared plus 21 squared is going to equal c squared, or hypotenuse. So that's going to be 400 plus 441 equals c squared. That's going to be 841 equals c squared. To cancel out the square, we need to take the square root of both sides. Okay, so that would be 29 equal to c. So our hypotenuse is 29. Okay. Now, when you do this and all your numbers are whole numbers, we call this a Pythagorean triple, because all the numbers are whole numbers. So we'll come back to that in a little bit. But if you have all whole numbers for A, B, and C, it's called a Pythagorean triple. Okay. Now take a minute and do number 1 and number 2 on your own. And give you the answer to the first one just to make sure you're doing it right in 1 second. Now for for number 1, you would have got C equals square root of 208. And since this is not a whole number, this would not be a Pythagorean triple because you can't take the square. You can take the square root of 208, but it's not a whole number. So that's how you find the hypotenuse. Now we're going to work on finding the legs, one of the legs. So here you just got to do some inverse, some opposite of what you did last time. So for one of your legs, you have 8 squared. We don't know the other one, so we leave that as a variable. And instead of C, we know the hypotenuse is 20. So we got 20 squared. Okay? So now we got 64 plus B squared equals 400. Use inverse operations. Take 64 from both sides. B squared is equal to 336. Take the square root. So B is the square root of 336. That is not a perfect square, so we just leave it like this. Okay. And since this is not a whole number, the square root of 336, it is not a Pythagorean triple. So I want you to do the next two on your own, but I wanted to give you a hint on number 2 because one of the sides has a radical. So when you do a number with a radical squared, right, you're going to do, that's one of the legs. So it's going to end up being radical squared. Those are the opposite of each other, so it just cancels out. So the square root of 7 squared is going to be equal to 7. I lost power. Hold on 1 second. Okay, got my power back. So as I was saying, the square, taking the square of something that's in a square root, it just cancels out. So root 7 squared will just be 7. So it's not going to be 7 squared, it's just going to be 7. So be careful of that. Now I've been talking about Pythagorean triples because for these three you have to say whether they're Pythagorean triples or not. And that's just when you do a squared plus b squared equals c squared, your answer should be whole numbers. Okay? So I'm going to show you the first one, number 3. I'm going to say whether it's a Pythagorean triple or not. So remember, Pythagorean triple means whole numbers. Okay. So here, we're trying to find our hypotenuse. So we're going to be adding. So we got 6 squared plus 8 squared equals c squared. 636 plus 64 equals c squared. Make that a little prettier. 36 plus 64 equals c squared. That's 100 equals c squared. Take the square root. 10 equals c. So since we got 6, 8, and 10, because they're all whole numbers, yes, this is a Pythagorean triple. So if we do 4 and 5, and one of them you have to leave in the square root, then it's not a Pythagorean triple. Okay. Last thing I need to show you. Okay. Is, like I told you earlier, if a squared plus b squared is equal to c squared, then it is a right triangle. Okay? But those are not our only options now. So a squared plus b squared could be less than c squared. Okay? Then it's going to be an obtuse triangle. So if when you a squared plus b squared, if it's less than c squared, it's obtuse. If a squared plus b squared is greater than c squared, you're going to have an acute triangle. Okay? What should you always check for also? You need to check and see if they're equal first. Because if they're equal, you got a right triangle. So check and see if they're equal. Because if they're equal, you got a right triangle. Okay? Now let me show you what this looks like if it's not a right triangle, if it's not equal. So for number one, they don't draw a diagram. We can draw one. You can do 6, 11, and 12. Okay. So we have 6 squared plus 11 squared. And then we have 12 squared. Now I'm not going to put the equal sign because we don't know if they're equal. We got to add them up to see. So we got 36 plus 121. And then 12 squared is 144. Okay. You could look at that and probably see that it's going to be bigger. 36 plus 121, which is going to be 140 and 57. 157. And that is bigger than 144. It's greater than, so we have an acute triangle, not a right triangle. And if we went over here, we got, well, actually, we don't know if it's right yet. So let's leave that off. Okay. So we can only put the right angle if we know that it's right. So I shouldn't have put that up there either. So we know that this is the hypotenuse, not because of the right angle, but because it's the biggest side. So that's one thing to be careful of. Okay? Because we don't know if it's right yet. So we got 33 squared plus 56 squared. And we want to know how that relates to 65 squared. So 33 times 33 is 1,089. 56 times 56 is 3,136. And 65 squared is 4,225. Okay. And when you add these up, you're going to get 4,225. So they're equal to each other. Okay, so if they're equal, we can say that it is a right triangle. And now we can add our right angle in up here. Okay, so for this one, I actually made a little boo-boo. This one is not a right triangle, so we don't have a right angle. So we just got some kind of triangle, actually an acute triangle with 6. Let me not draw it so that it looks right. We got 6, 11, and 12. But it's not right. So number 1 is acute because it's bigger. Number 2 is right. Now do the 3 at the bottom on your own. Again, remember if you have, like in number 4, you have the square root of 74. So when you do the square root of 74 squared, that's just going to be 74. You don't do 74 squared. The answer is just 74. So use that as a hint to figure out whether the triangles are acute, obtuse, or right. And then on the back page, we have a project. Not a project. A small assignment that we got to do. So quiz next class. This is something you're going to have to do on there. So make sure you know how to do that. And this is our little assignment, but I'll go over that in class. Okay, that was lesson number 2. See you next time.